I'm Stephen.
And I'm Dale, and this video is going to give an overview of our final year software engineering group project. The project delivered a system that can monitor, control, automate and analyse the environment where it is located.
You can customise a selection of motors and sensors that can be added anywhere within reach of your home wireless network. Also, your smart house can be controlled from anywhere with an internet connection using our website or Android app.
The smart house uses a range of electrical components that react to the environment.
An interactive website to control your house and view data.
A logic engine to process data and generate system actions.
An Android app to interface with your house on the move.
And an active RFID mapping system for asset tracking.
Those were the 5 key components that form the smart house system. Now Dale will explain his part of the project.
Okay, my part dealt with the electronic components of the system and used a modular approach, so let's take a look. Okay, this is the modular physical prototype that was created. Elements 1 and 2 are actions associated with your front door, being opening and closing, locking and unlocking. Elements 3, 4 and 5 would typically be placed in your living room or hallway. Element 6 represents miscellaneous sensors that could be placed throughout the house. And I'm going to show you how these link together and link to the system. Okay, here's an example of 3 typical analog sensors, being light, temperature and motion. Also, there's an LED which indicates whether the heating is turned on or off. These are connected to this basic interface kit, which can house up to 8 sensors and up to 8 LEDs. So here are examples of other sensors. It could be a force sensor, it could be a touch sensor, it could be an infrared sensor, it could be a magnetic sensor, which we have here. So under this black strip is a magnet, on the other side is a sensor, which looks similar to this, but detects magnetism. So when you open and close the door, it will detect that it's been opened or closed. So this is the back of the curtains. Attached to the servo motor is a blue disc with some string which lifts the curtain up and down. This is the controller board which houses up to 8 servo motors at any one time. Each controller connects to the PC via USB cable. This is the wireless interface kit which allows the controllers to be connected to this. It allows up to 4 and it works wirelessly through the home router. This is an SBC or a single board computer running Linux, and it allows for the code to be directly uploaded and enables the system to run autonomously without a PC. Okay, so when the system is running, the sensors have predefined levels and send events when those levels are breached, which you can see in the top graph. Every second, the system flashes the sensors to get the latest sensor reading. After 60 seconds, the data is averaged out to give a minute reading. This is then passed to the system on the website, and it's also used to populate the graph. Okay, so that was a basic overview of the system, and now it's over to Rick with the active RFID.
Hi, my name's Rick. My part of the project covered the active RFID asset tracking system. Now let's see this in action. Okay, my name's Rick and I developed the RFID asset tracking system for the smart house. This is the screen you're presented with when you launch the software, engine IP, username and password. So let's log in. When you log in, you're presented with a table of tags. These aren't actually tags, these are simulations of the tags. One is the laptop and one is the eCow active RFID tag activator. We get zones. These are for the implementation of tracking, so we can create rules, remove rules, load rules and start tracking, but again these are only used for the tags. We can send buzzers to tags, so this will send an alarm on the tag like a sound, and we can send a message to a tag again. These would only work if we had tags in the system. So we can view tags on a map. When we click view tag on map, we're presented with this, the location of the tag and the coordinates. These update every 15 seconds, and it also updates the image on the Smart House website.
Hi, I'm Tom. My part of the project is the logic engine. The logic engine generates actions for the house based on sensor readings.
The following features are included. It's an always-on process, which listens to breaches posted from the server. A breach is when a degree of change occurs in a sensor. Once a breach has been received, it uses decision tree logic to decide on a course of action. Once a course of action has been decided, it is encoded in JSON, which in turn is passed to the server and activated by the client machine. The following functionality is included. Light sensor logic. When a zone is dark, lights are turned on and curtains are closed. When the zone is light, lights are turned off and curtains are opened. Temperature sensor logic. If an abnormal temperature is detected in a zone, an alert is posted to the server. This alert could indicate a potential fire or other hazard. Movement sensor. When a room is empty and no movement has occurred, the room is set to idle, meaning lights will be turned off. RFID and magnetic strip door. To access a zone, you can use an RFID card, which opens a servo. When the door is closed, a magnetic strip is used to indicate that the door has been closed and the lock is reactivated. Holiday mode. To simulate a user or person being at home, the user is able to set holiday mode using the website or mobile app. Holiday mode is when a light pattern is generated and curtains are closed to simulate somebody being at home. This mode is also monitored, so if movement occurs or a door is opened, an alert is posted to the server to warn of this. All functionality is logged using a MySQL database.
Hello again. It was my part of the project to develop a website that allows users to control the smart house, as I'll now show you. Here we have the Smart House website prompting for a user to log in, like so. This takes us through to the Smart House dashboard. The dashboard is laid out with containers of information and controls that can be dragged to the position of your liking, so we can move these around like so. Let's put it back to how it was. The central column contains controls to switch the devices in the home. So if we'd like to turn this living room light on, like so. All activity on the home's devices are logged and displayed in the recent activity column on the left over here. Below this we have a home tracker container. This container presents a map that displays the current location of an RFID tag subject. If we go to the upper right of the dashboard, we have an alerts container which displays any system alerts that have been detected in the last 7 days, such as a break-in or fire, etc. Below this we have a statistics container. This previews a device statistics graph of yesterday's activity. Finally, on the upper left we have a mode container. Here we can perform batch operations on devices. Say if we wish to switch everything off in the house, like so. This would switch off every device in every single zone. Or if we performed an emergency evacuation mode. This would unlock every single door lock and switch on all the lights so people could escape the house and see where they're going safely. If we go to the Manage Devices section, here through to Dashboard, to add, edit, remove certain devices and controls of the system. So as pointed out by Dale before, we have controllers which can be removed here. We can also add new kits and controllers here, selecting what type of connection they have. We can also add new devices to the system, say a sensor, or if we'd like to, say a servo motor. Give the motor a name, say kitchen curtain. If we go to the Manage Zones section, we can add a new zone, say that kitchen, as well as removing zones. A user can be created, including their email address, so the house can email them in the case of an alert, and also and access level. The reason for that is to prevent unauthorized users from deleting administrative users. For example, if a user such as Dave here, who is a standard user, try to log in to delete his parents, for example, you get an access denied, preventing him from doing so. Holiday mode. If users were going away, the house would act as if someone was at home, say switching lights on and off, opening and closing curtains, for example, between certain dates as selected and submitted before you were to go away on holiday. That was an overview of the Smart House website.
Hi, I'm Sarah, and I was responsible for creating an alternative method of interfacing with the Smart House system in the form of an Android app. Now here's a brief demonstration. So let's select the Smart House Settings app. First of all, we need to choose the server to connect to that will relay instructions to the house. Once connected, each user of the app has a username and password that they must use to log on to the system. Once logged on, a menu displaying the different options is shown. Let's take a look at the Settings option. Settings can be viewed either by their type or the zone that they are in. For the purposes of this demonstration, we will look at the settings in a particular zone. Selecting the living room displays the settings for this zone. If we change the living room lamp to on and save the changes, this then updates the house. Let's now take a look at the Users option. This displays a list of user accounts within the system. The app also allows for user accounts to be created, edited and deleted. So if we create a user, we then need to fill in the fields, such as the username. Once all the fields are filled in, we save the user, and this updates the system. If we then go back to the user list and refresh the users, we can see that the new user has been added into the system. Holding and pressing on a user displays the options. If we delete this user and confirm our deletion, then the user has now been deleted from the list and from the system. So let's take a look at the House Modes option. Modes can be activated in the house from the app. If we activate the full lock mode and run it, all locks in the system will now be set to on. Now let's take a look at the final option, Proximity Settings. By clicking the Start Tracking button, my location will be tracked. I am already in proximity to the house, so when I click the Start Tracking button, the heating is activated. That concludes the demonstration of the Smart House Android application.
That was a breakdown of our final year software engineering group project.
Systems like this will inevitably become more popular in the future, and it could only be a matter of time before you find a system like this in your home.
We hope you've enjoyed watching our video. Thank you for watching.